In this note, we're going to look at two terms, induced charge separation and grounding. So induced charge separation is the first thing we're going to look at, and this is when a charged object is brought close to a neutral object. And when that happens, it will induce a charge on the neutral object. So this is similar to charging by conduction. However, the objects are not touching. And this is specifically between a charged object and a neutral object. So what happens is the charges that are similar to the charged objects are pushed to the opposite end, and the closer end of your neutral object becomes oppositely charged. So this makes the neutral object attracted to the charged object. And we'll look at an example in a second. So here we have a negative balloon and a neutral wall. So the negative balloon is going to come close to the neutral wall, and what's going to happen is that because the negative balloon has more electrons, it's going to push those electrons or those negative charges away in the wall. So that's going to leave the surface to be mostly positive because the negative charges have been pushed away. Again, we're going to want to refer back to the fact that like objects repel and unlike charges attract. So the negative charges in the balloon are going to repel the negative charges in the wall, and then the positive charges will then be attracted to the balloon. So again, as the balloon comes closer, the negative charges move away, and then the positive charges are left. That doesn't mean that the wall changes its charge. It's still neutral, it still has the same amount, but there is an attraction between the two because those negative electrons have been pushed away, and you have a positive surface now. Grounding is when objects have their electric charge removed. So this often removes the excess charge by transferring electrons between an object and between a large neutral object, such as the Earth. So if we have an object that is charged, if we ground it, we're taking away the excess electrons and putting it into a large neutral object, something that can absorb all those negative charges. This is basically what the symbol for a ground is. We're going to look at something like this, or you may see something like this in electric circuits or in circuit diagrams. But essentially, when a positively charged object is grounded, electrons from the ground travel into the object until it becomes neutral. So we're adding electrons to this positively charged object to make it more neutral. And when we have a negatively charged object, when we ground that, the electrons from this object travel into the ground until it becomes neutral. So we're removing those negative charges. And a shock is something that can occur when a lot of electrons are transferred quickly between a negatively charged object and a grounded object. And we'll look a little bit at this later, but this is essentially what lightning is. But again, the key terms that we wanted to look at were induced charge separation and grounding.